Hi, everybody. We're continuing our discussion on Chapter 9 on reactions of ions, and we're going to talk about single replacement redox reactions. And a lot of what we're going to cover in this section is going to be very similar to things we've already learned in the previous exams material on single replacement reactions. So if you're pretty familiar or did pretty well on that concept, it'll be pretty easy here, I think, as well. We're just adding one thing to that. But if you were having trouble with that section, go back, review those videos on single replacement reactions, kind of do the homework, look back at the exam, and kind of catch yourself back up so that we'll be able to do this section more easily. So like I said, single replacement redox reactions. And just a quick summary then, like I said, go back if you're having trouble with single replacement reactions, but here's a summary of them, all right? So you have this general formula here, equation type for a single replacement reaction, where some element A plus a solution of either an acid or an ionic compound represented by Bx here reacts, okay? And you're gonna get an ionic compound, usually in solution, okay, that would mean aqueous, right? Ax here, plus the element B kicked out of where it was bonded before or connected before in this ionic compound. It got kicked out of that ionic compound. So here's an example of one. I don't even know if this is the right picture for this reaction. Probably not. I think I switched it when I did my notes. But regardless, these are the type of reactions that we've seen before when we did single replacement reactions. So again, this is kind of review to begin with, where we have A plus Bx gives me Ax plus B, okay? So again, this is just review, but if you had trouble, go back and watch those other videos on single replacement reactions. All right, so let's just do an example. Okay, so again, so we're caught up on this idea of single replacement reactions, and then we'll talk about what we mean by these redox reactions, okay? So we want to write the net ionic equation for the reaction that occurs when a chip of calcium is placed in a nickel chloride solution. So I've already given us the reaction here. So remember, when we're going to write the net ionic equation, we break up everything that's aqueous and we leave together solids, liquids, and gases, okay? So in other words, we're going to begin by breaking everything that is aqueous here into its ions. So calcium is a solid plus, so we're going to get a nickel ion, because remember, this is A and Bx. So we want to break apart this guy. So we want to break apart right there. Okay. And it has a 2+ charge, okay? Because if I just erase here a little bit, this 2, right, came from the nickel. Because again, the compound needs to be neutral when you put it together, or balanced its charge. And the chloride ion, again, if you look at your charts on ions, which you should have in front of you, the chloride ion has a -1 charge. So I need 2 of them to balance out with the nickel ion that has a 2+ charge, okay? So that's what I mean, I guess, by the 2 came from the nickel, if you do the crisscrossing trick that we talked about, okay? So there's several ways you could look at it. So I just wanted to point that out. Okay, so this is nickel aqueous plus 2 chloride ions. Again, each chloride ion is a -1 charge. So I see that problem a lot where people will write this, okay? That is wrong, okay? That is chlorine, the element. That's not a chloride ion, okay? So when you see aqueous here, okay, when you see aqueous here, that's a clue that the thing I'm breaking things up into should be ions, okay? They shouldn't be diatomic elements or things like that, okay? So you got to look at your ion chart. So this is a chloride ion, and I have 2 of them. Okay, gives me, okay, calcium, aqueous, plus 2 chloride ions. Oh, I'm running out of room. Plus nickel solid. Okay, so that would be the total ionic equation, if you remember from previous videos. I have the chloride ions on either side, so they cancel. So what I'm left with is calcium plus this nickel ion here gives me calcium ion plus solid nickel. Okay, so that's the net ionic equation. All right. So again, just review to catch us up on things we've already done for single replacement reactions. Now we're just kind of building on that as we're going to see in the next slide. Okay, so what I just wrote there, the net ionic equation, is a redox reaction or an oxidation reduction reaction. Because electrons, if we got down there on the particulate level and we were looking at that level of what's going on with the electrons are being transferred from one species to another. Okay, so remember these positive charges of the ions means I'm either losing electrons, or if I had a negative charge, it means I gained an electron, okay? So from this net ionic equation, we could see that solid calcium becomes the calcium ion, which has a 2+ charge, which means it lost 2 electrons, okay? Going from here to here. And then the nickel ion gains 2 electrons, right? Because it had a 2+ charge. Now it has no charge, it's neutral, and becomes solid nickel. Okay, so you have this transferring of electrons going on in this reaction. Okay, so from here, okay, well, first let me pause there. Okay, so how do we tell then if we're given a certain material, let's say, like if a problem said iron is put in a solution of silver nitrate, how could we tell if a single replacement reaction actually is about to happen? How can we tell if the reaction is going to go at all? Okay, and if we're going to get this redox reaction going on? Well, that's what's listed over here. We can use something called an activity series, okay, given in this table here that you can use for reference as we go through the problems together in the next few slides. And this activity series lists the relative reactivity of species that form positive ions in these single replacement redox reactions. So if we look on the chart here, calcium, okay, if we thought of this as a scale, okay, increasing activity, all right, calcium is higher than nickel on the activity series, okay, it's above it. This means that calcium will replace nickel in a single replacement reaction, okay, like the one we have written here. However, if this was opposite, if solid nickel was placed in a solution of calcium chloride, there would be no reaction because nickel is below calcium on this activity series chart, okay? So it's going to be very helpful for us as we do a few example problems to figure out what's going on, okay? So let's do that together. We want to write the conventional total ionic and net ionic equation for the following reaction here. So we have zinc is dipped into a solution of copper 2 nitrate. Okay, so let's see if I have enough room here. I hope so. So zinc, well, that would just be a solid, okay, plus copper 2 nitrate. I'm going a little faster putting the compounds together because we've had a lot of problems doing that. A lot of example problems. I hope you haven't had problems doing it. So that's copper 2 nitrate. What's going to happen here? Well, I have this formula, A plus Bx gives me B plus Ax. Yep. I don't know why that looked wrong for a second. So what we're going to get is copper solid plus zinc nitrate. Okay, now what we have to check then, I actually kind of skipped a step about the activity series, so excuse me for that. We have to see if zinc is above copper on the activity series, okay? Because it's replacing copper in this reaction, okay? So let's see here. We have zinc, okay? And we have copper. So it is. So that's kind of why I skipped a step there, not even realizing it. So I apologize for that. But because zinc is higher than copper on the activity series chart, this is valid. Okay, this reaction can happen. Okay. And these zinc is, as we'll see in a second, has a 2+ charge. Okay, so that's why I kept that 2 there. If zinc had another charge, right, I would have to balance the compound's charges and then balance the equation. But in this case, the equation is already balanced to keep things simple for us. So this would be the conventional equation, okay? So this is the conventional. Okay, so let's do total ionic. Okay, so I'm just gonna erase this actually, because that gets a little confusing, but I'll keep the total ionic there. Okay, so total ionic, we break up everything that's aqueous, right? So we're gonna have zinc, copper, ion, plus 2 nitrate anions, copper solid, plus zinc ion, plus 2 Q. Okay, so that's the total ionic, right? We broke apart everything that's aqueous, and then net ionic. Okay, the nitrate ions are the same on either side. Get rid of them. We're left with zinc solid plus copper 2 ion solid plus zinc plus aqueous. Okay, so there you go. So really the only thing different than what we've done before is using this activity series to see if the reaction will continue or not, or will happen or not. Okay, so there we go. That's the answer for this one. Let's do another example. And this one, why don't you do on your own actually? So pause the video, do exactly what we just did, use the activity series, and then we'll do it together. Okay, so let's do the conventional first. So we have calcium. I'm just going to go kind of fast here. Placed in hydrobromic acid. It's a strong acid. So if you remember from that video, it's going to completely break apart when we do the net ionic equations. It gives me hydrogen gas plus calcium bromide. Okay, aqueous. So, okay, we have to balance this, and we're going to do that by putting a 2 there. Okay, because remember the calcium ion had a 2+. I'll just be quick about this. Bromide ion had a -1 charge, so I need 2 of those there to balance it out. Okay, so that's the conventional. So now total ionic. Okay, so we have calcium, and we've done similar problems to this before. Plus, well, I'm skipping it again. Okay. Calcium is way above hydrogen on this chart. And it says here, calcium will replace H2 from liquid water, steam, or acid. So this reaction is going to occur. Okay. So calcium, again, is above hydrogen on here. The next one I'm not going to forget. All right. The next one I'm not going to forget for sure. I'll probably forget, but I'm going to really try not to. I just want to write the equation and then I do all this work and check later and realize, oh, I didn't actually have to do that. No reaction was going to happen. So I just wasted my time. So check the chart first. Don't be like me. Okay. H2 gas plus calcium plus 2Br minus. Okay. So that's the total ionic, net ionic. Okay, that's gone, that's gone. Okay, calcium plus 2 protons, H2 gas, plus calcium 2 plus aqueous. All right, one more problem, I believe. Silver is placed in a solution of copper nitrate. Okay, so I'll just write out the first part here. So silver is placed in a solution of copper nitrate. Okay, will this happen? Well, let's check. Okay, so now I remember. Is silver above copper on this list? Let's check here. Copper is here, but silver is below copper. So it will not replace it in this reaction. So this is, you'll just write no reaction, or no, you could spell out reaction. This is kind of a shorthand for reaction. Okay, so that's it. We're done. So again, we didn't have to do all of that hard work when you check the chart first, okay? The other two examples, I guess we got lucky. And this one may be written a little bit different in the notes. It might have copper placed in a silver nitrate solution. So you can do that one. If that's the case, I'll recheck or see however these videos get posted. But if you're watching this video and it's a little bit different, try to do the one that's in your notes and then try to realize why this one is different, okay? So I think that's it for this chapter, or this section. It is, and hopefully that makes sense. We're going to go into double replacement precipitation reactions, which again is just building on things that we already learned, but it's going to add a little wrinkle to it. So I'll see you there.